Hey guys, Professor Calculus is here, and in this video today we're gonna be solving this integral right here, which is very terrifying looking but has a solution that is very simple. Not simple, but simpler than you think. Before that, make sure to like and subscribe as it is free and you can always change your mind later. So I've already done the integrals like that in my videos, so you probably know the approach, but I'm gonna redo all these steps for the ones that do not know. So if I have a number x, I can raise it to the power of e to the ln of that number, ln x. So we're gonna use this property here. So we're gonna use this property and we're gonna say our integral is equal to e to the ln of x to the I dx. My I is e to the x to the I ln x dx. Now here you should remember that we got a series for e to the x, and e to the x series is the infinite sum from 0 to infinity of x to the n over n factorial. And if I plug in x to the I ln x here, in here, I'm gonna get e to the x to the I ln x to be equal to the infinite sum from 0 to infinity of x to the I ln x to the power of n, the number that I had right here, over n factorial. Thus I can replace it here, and I is going to be the integral from, so let me write it here. I is going to be the integral from 0 to 1 of the infinite sum from 0 to infinity of x to the I ln x to the n over n factorial dx. And I can move this summation notation and this n factorial out here because they are constants. So n equals 0 to infinity of 1 over n factorial, the integral from 0 to 1 of x to the I ln x to the n dx. I can distribute this n to every one of these terms here, and I is going to be the infinite sum from 0 to infinity of 1 over n factorial x to the I n ln to the n x dx. Now I'm going to be able to define a variable substitution here to make this work more simple. I'm going to define t to be negative ln x, and as a result x is going to be e to the negative t. Thus dx is negative e to the negative t dt, and my bounds when x equals 1, t equals 0, x equals 0, t equals infinity. Now I is the infinite sum from 0 to infinity of 1 over n factorial, so from infinity to 0. My x is e to the negative t, in, ln x is negative t, dx is negative e to the negative t dt. Now this negative number can be absorbed in this integral and flip the sign of the integral here. Sorry, flip the boundaries here from 0 to infinity, e to the negative t in, negative t, forgot to the power of n here, e to the negative t dt. And I is the infinite sum from 0 to infinity 1 over n factorial, the integral from 0 to infinity e to the negative tin minus t, negative 1 to the n, t to the n, dt. I therefore is the infinite sum from 0 to infinity 1 over n factorial. I can move this one out here as well. So I'm going to do that. Negative 1 to the n over n factorial, the integral from 0 to infinity e to the negative t times in plus 1, t to the n dt. Here I'm going to do another substitution. I'm going to define u to be tin plus 1. Thus du is dt times in plus 1. dt is du over in plus 1. My bounds are going to be the same because it's multiplied by a constant. Multiplying 0 by a constant gives you 0, and constants do not have any importance when we're talking about infinity. So I'm going to do this substitution here. The infinite sum from 0 to infinity, negative 1 to the n over n factorial, the integral from 0 to infinity of e to the negative u, t to the n is going to be, my t is going to be u over in plus 1, so u over in plus 1 to the n, and dt is du over in plus 1. Thus I equals the infinite sum from 0 to infinity, and my integral would be to the negative u to the n over in plus 1 to the n times du over in plus 1. I can sum up these two powers here. So I'm gonna write it again. Du over in plus 1 to the n plus 1. I can move this one out. And I is going to be the infinite sum from 0 to infinity of negative 1 to the n over n factorial in plus 1 n plus 1. The integral from 0 to infinity e to the u to the n du. And this integral here actually is equal to n factorial. I'll prove it in another video, but this is going to cancel out with this n factorial here, and therefore my I is the infinite sum from 0 to infinity of negative 1 to the n over in plus 1 to the n plus 1, and that's my answer as an infinite sum. Therefore I'm going to write this here, negative 1 to the n over in plus 1 to the n plus 1. And that is the final neat result of my integral that I obtained here. Hope you enjoyed this video. Please let me know if you have any questions, and I'll see you next video.